In this section, we're talking about mixed expressions and complex fractions. A mixed number contains the sum of a whole number and a fraction. So you know from earlier classes that 5 1/3 is an example of a mixed number, but also a mixed number can contain the sum of a monomial and a rational expression like this. So both of those things, 5 1/3 or 3 plus 7 over x plus 2, both of those are considered mixed numbers. A complex fraction is a fraction with additional fractions in the numerator and the denominator or both. So you can see this example of a complex fraction. It's a fraction within a fraction, pretty much. You can rewrite a complex fraction as a division expression. So you would multiply by the reciprocal of the denominator. To simplify this mixed expression, you would change it into a simple rational expression with the same denominator as the given expression. So I'm going to show you how to do those things in the next slide. Write 3 plus 7 over x minus 2 as a rational expression. We have to get a common denominator. So we kind of did this a little bit in the last section, but I want to show you. So 3 plus 7 over x minus 2. The 3 is over a 1 right now. So to get it to write it as a rational expression, we have to get a common denominator, which would be the x minus 2. Whatever you do to the numerator, the denominator you have to do to the numerator. Okay, so I could rewrite this as 3 times x minus 2 over x minus 2 plus 7 over x minus 2. So if I wrote that all as one fraction, how we need to do would be over x minus 2. I would distribute the 3, so 3 times x is 3x. 3 times a negative 2 is negative 6, and then I could write that plus 7. So to get my final answer, I would just combine like terms. So 3x, negative 6 plus 7 is a positive 1 over x minus 2, and that would be my final answer. In this problem, I'm going to be showing you how to simplify a complex fraction. So it's a fraction within a fraction. So you know that when you're dividing by fractions, you have to multiply by the reciprocal of the denominator. So I'm going to rewrite the numerator, a to the 5th b over c squared, and then multiply the denominator. So instead of ab to the 4th over c to the 4th, I'm going to rewrite that c to the 4th over ab to the 4th. So I'm going to multiply by the reciprocal of the denominator. And now I can simplify. So you can either write it all at one time and then simplify, or you can simplify as you go. I guess in this problem, I'll just multiply first. So I've got a to the 5th, b, c to the 4th, over a, b to the 4th, c squared. Now I'm going to simplify that. So I have 5 a's in the top and 1 a in the bottom. So that means I have 4 more in the numerator. B's, I have b over b to the 4th, which means I have 3 more b's in the denominator. And c to the 4th over c squared, which means I have 2 more c's in the numerator than in the denominator. And that is my final answer. Number 3, I have b plus 2 over b plus 3, all over b minus 4. So we have a lot of fractions. So I have a mixed number over a binomial. So what I need to do is I need to change this mixed number into one rational expression. To do that, I need to get a common denominator, which would be the b plus 3, because it's the only denominator I have. So I need to multiply this by b plus 3 and b plus 3. So when I do that, I would get b times b plus 3 over b plus 3 plus 2 over b plus 3 all over b minus 4. Now I have a common denominator in the numerator, so I'm going to say b plus 3 over, I'm going to distribute that b, so b times b is b squared, b times 3 is 3b, and then I have the plus 2 and that's all over the b minus 4. All right, now this b minus 4 is also in a fraction. It is assumed to be over 1. That's important in a little bit. Okay, now the next step that I'm going to do is I'm going to factor this numerator because I've got a lot going on right there. So I'm going to say, what times what gives me b squared? B times b. What times what gives me 2? That adds together to give me 3, a 2, and a 1. And then I'm going to keep it over the b plus 3. And that's over this b minus 4 over 1. Now I have a complex fraction. I think that's fair to say. It's very complex. So I have a fraction within a fraction. What do? We multiply by the reciprocal of the denominator. So I'm going to write the numerator as it is, b plus 2 times b plus 1 over b plus 3. Instead of dividing by b minus 4 over 1, I'm going to multiply by 1 over b minus 4. When I do, I can't simplify anything. So my final answer, I'm just going to multiply across, and I would get 1 times b plus 2, b plus 1, the 1 is assumed, over b plus 3 times b minus 4. And that is as far as I can go. I can't simplify because none of the binomials are the same. All right, and number 4, I have a complex fraction that needs to be simplified. So the first thing that I'm going to do is I'm going to start to simplify and factor all of these fractions. So in the first numerator, I have c squared minus 4c plus 3. If I factor that, what times what gives me c squared? C times c. What times what gives me 3? That adds together to give me a negative 4, a negative 3, and a negative 1. Okay, now that denominator. So what times what gives me c squared? C times c. What multiplies together to give me 14? That adds together to give me 9, a 2, and a 7. Okay, all of that is divided by this other fraction. So right here we have a difference of squares. All right. So if we factor that, what times what is c squared? C times c. What times what is 9? 3 and 3. One has to be positive, one has to be negative. And that's over c plus 2. So now everything is factored. So my next step would be to multiply by the reciprocal of the bottom, because when we're dividing complex fractions, we have to multiply by the reciprocal of the denominator. So I'm going to write the numerator as it is. So c minus 3 times c minus 1 over c plus 2 times c plus 7. Now that's going to be multiplied by the reciprocal of the denominator. So c plus 2 over c plus 3 times c minus 3. Now let's simplify where we can. Okay, so I have a c plus 2 I can cancel out, and I have a c minus 3 that I can cancel out. So my final answer is what's left. So I have c minus 1 over c plus 7 and the c plus 3. And that is my final answer. Number 5 is a word problem. Sam is 67.5 inches tall and weighs 152.5 pounds. What is his ratio in pounds? In pounds per inch of height. Okay, so we're wanting to do pounds over height. It is not always written in the problem like they want you to write it in the answer. So for instance, in the problem, if you read it, Sam is 67.5 inches tall. Well, in the problem, they want us to do in pounds per inch of height. So the 67.5 is actually going to go on the bottom. And then he weighs, so that would be pounds, 152.5 pounds. So now you can see that you're just doing fractions. There's no variables in this. So we are going to get an improper fraction in the numerator and the denominator. So 2 times 152 is 304, plus 1 would be 305, and that's over 2. That is over 67 times 2 is 134, plus 1 is 135 over 2. And now we simplify that by multiplying by the reciprocal. So 305 over 2 multiplied by 2 over 135. 2's would cancel out. And I can divide these. If I did, it would simplify to 61 over 27, which I can write as 2 and 7 over 27. So what is ratio in pounds per square inch of height? A ratio I actually want to leave as an improper fraction, so I can write that 61 to 27 or 61 over 27, either way. Number 6, we have rational expressions and a complex fraction. So we've got 1 minus 1 over x plus 4 all over x plus 4 plus 2 over x plus 1. To simplify things a little bit, I'm going to put the 1 over 1 and the x plus 4 over 1, because that's what they're assumed to be anyway. So I'm going to write this. My common denominator in the numerator would be x plus 4. My common denominator in the denominator would be x plus 1. We know that because those are the only denominators in the numerator and the denominator right now. All right, so what we're going to have to do is we're going to have to multiply x plus 4, top and bottom right there, and then we're going to have to multiply x plus 1 in the bottom. Okay, so what does that leave us with? That leaves us with x plus 4 times 1, which is x plus 4, minus 1. I'm getting minus 1 from right here. All right, now in the denominator, I have x plus 1 times x plus 4, and then that plus 2. So as you can see, this is already getting kind of complicated. You can pause this and look at it if you would like to. So in the numerator, I'm going to get like terms together. I would get x, 4 minus 1 is 3, so it would be x plus 3 over x plus 4. And then in the denominator, I am going to multiply this x plus 1 times x plus 4 right here. When I do that, I would get x squared plus 4x plus 1x plus 4. And then I have that plus 2 out to the side, and that is all over x plus 1. All right, so my next step would be to simplify that a little bit. So we've got x plus 3 over x plus 4. That is all over. Let's get this together. Okay, so we've got x squared, 4x plus 1x is 5x, 4 plus 2 is 6, and that's over x plus 1. Now, hopefully you see that that can be simplified or factored. So I'm going to leave the x plus 3 and the x plus 4 alone for now. That is all over this x squared plus 5x plus 6, which I can factor to x plus 2 times x plus 3, because 2 plus 3 is 5 and 2 times 3 is 6. And that is over x plus 1. Now, all right, so when I have a complex fraction, I'm going to multiply by the reciprocal of the denominator, right? So I get x plus 3 over x plus 4 times, I'm going to multiply by the reciprocal here, so x plus 1 over x plus 2 times x plus 3. Is there anything at all that I can cancel out? Yes, there is. It's x plus 3. That's as far as I can go. So my final answer would be x plus 1 over x plus 4 times x plus 2.